Hello my dear students of class 10. Today we will do theorem number 2 from the chapter 10, circle. The name of the chapter is circle from chapter 10. So we will learn theorem 2 with proof. So see what is the question. I have said like this: prove that the length of tangents drawn from an external point to a circle are equal. So look at the figure. Here is a circle with center O, and I have taken here a point P outside the circle. So from the point P, first we have to draw two tangents. So let us draw the two tangents here from P. So I draw a tangent here, see, like this, and from P we draw another tangent here. So you have to know what is a tangent. A tangent is a line that intersects the circle at one point only. So if you look at this tangent, it has cut the circle at one point only. We can name it, say, A. And this tangent has cut the circle at one point only. We can name it here B. And here we can give arrow mark. Okay. So now we have what is right here. We can write given. So given, we get it from the question. So a circle, what is, with center O, we can write given a circle with, if you write a circle, here is O comma R, it means a circle with center O and radius R, full stop. And two tangents, these are the two tangents, PA and PB. We can write here two tangents PA and PB from an outside point P to the circle. So this we get from the question. See, prove that length of two tangents drawn from an external point, external meaning outside point, external point to a circle are equal. So from the question we get this: a circle with center O, radius R, and two tangents as we have drawn here. What name we have given? PA and PB from an outside point. This outside point is P here. From here we have drawn two tangents to the circle. And now what we have to prove? We write here to prove. See, prove that. We have to prove that this length of these tangents are equal. It means PA and PB, they are equal. So we write to prove PA is equal to PB. And now see, this figure is not sufficient to prove the theorem. So we need some extra part. We call it construction. So here is that extra part will come, construction. So for the construction, see what we have to do. We have to join the center O and this point A. So we join by dotted line, and have to join this point O and the point B. Okay. So this will be what? The radius. OA is a radius, OB is also a radius, and we need to join also this O and P. O and P. So join this O and P. So what we have done, we will write here construction. We join OA, comma OB and OP. Okay, we have joined OA, OB and OP. And now the next part of the proof will come. This is proof. So for the proof, see, from the theorem number 1 we have learned already a tangent and a radius is perpendicular. So this tangent PA is perpendicular to the radius OA, and similarly this tangent PB is perpendicular to the radius what? OB. So they are perpendicular. Let us write that proof. The PA can write here, since PA perpendicular to OA and this PB is perpendicular to OB. So this is the symbol of perpendicular to. Okay, this is the symbol of perpendicular to. We read PA is perpendicular to OA. PA is perpendicular to OA and PB is perpendicular to OB according to theorem 1. If we write the reason, we can write here the reason, because what is tangent to a circle is perpendicular to the radius at the point of contact. This is theorem 1 actually, at the point of contact. This is a tangent, this is a radius, they are perpendicular. If they are perpendicular, this angle will be 90 degree and this PB perpendicular to OB, so this angle also will be 90 degree. So we write this. What is the name of this angle? OAP. So we write here, therefore angle OAP is equal to 90 degree, and here this angle OBP is also equal to 90 degree. That means we can say that this angle and this angle are equal. So we write here, therefore angle OAP is equal to angle OBP. Both of them are 90 degree, so they are what? Equal. Okay. Now it is very easy. So we have to prove that PA is equal to PB. So if we look this triangle OAP and this triangle OBP, between these two triangles we will find which parts are equal, which corresponding parts are equal. So let us write now, in triangles, what's the name? OAP and OBP. OAP, OBP. Between these two triangles, see which parts are equal. First we can see this is radius. OA, this is also a radius. They are radius of the same circle, so they will be equal. So we can write OA is equal to OB. Why they are equal? They are radius of the same circle, so we can write radii. And one more is, see, this OP, from this triangle if we take a side OP, and from this triangle also one side is OP, so we can say OP is equal to OP. Here OP is equal to OP. Why are they? They are the common side. They are the common sides. And the third is this angle and this angle are equal. Already we have shown here. Okay, so we write that OAP, angle OAP is equal to angle OBP. OBP. So already we have proved both of them are equal to 90 degree. So what do we see? Between these two triangles, three parts are equal. See, OA equal OB, OP equal OP, and this angle equal this angle. So we can say these two triangles are what? Congruent triangles. So we can say therefore triangle OAP congruent triangle OBP. OBP. And why are they congruent? See, we have already said this angle is right angle. That means this triangle is a right triangle, and here also this angle is right angle. So this is also a right triangle. So between two right triangle, this radius among this radius, and this is the common side. So these two triangles are what? Congruent. That is a theorem. It is called by RSS. RSS congruency. RSS meaning RSS congruency. That means between two right triangle, hypotenuse and one side are equal. See here, these are the two right triangle. From here, the opposite, this is the hypotenuse. From here, this is the opposite, this is the hypotenuse. So hypotenuse equal hypotenuse, and one side from here, this is, one side from here, this is. So they are equal. So now we show that these two triangles are congruent. Congruent meaning they are equal in all respect. This is the symbol. Here is equal and this is a curved line. Okay, this is called congruent or equal in all respect. And now if two triangles are congruent, their corresponding parts are equal. So from this triangle, if I take the side PA, from this triangle the side PB will come. So we will write therefore PA is equal to PB. Why are they equal? It is called CPCT, corresponding parts of congruent triangles. So these are the corresponding parts of congruent triangle. These two triangles are congruent, so they are corresponding parts, corresponding side. PA is equal to PB, and we need to prove that. To prove PA equal to PB, so our proof is finished here, and we can conclude that proof is finished here. We can write here proved. So we can conclude that length of tangents drawn from an external point to a circle are equal. See, they are equal. So that is the end of the theorem. Okay, thank you, my dear students.